Are you ready to learn about the segment addition postulate? Hopefully you are, because it is just like the angle addition postulate. So notice we're going to be adding segments this time instead of adding angles. So notation is how we write something, and so you write line segments with a little line over the top. Notice you don't put arrows, and notice you don't put endpoints. You just have like a line. So the line segment AB means a line segment with endpoints A and endpoints B. And so AB means the distance between A and B. And so we measure distance in feet, centimeters, etc. To be in between something, it has to be on the line. So notice E is between C and D, but G is not in between C and D, even though it's in the space between it. It's not on the line in between it, okay? So the points must be collinear. So segment addition postulate says if Q is between P and R. So it helps if you draw a picture. So Q is between P and R. So P and R are my endpoints. And Q is somewhere in between there. It could be in the middle. It could be more towards P, whatever. So the first part would be this part, so PQ. So if I take the first part and add the second part, QR, I should get the whole entire line, PR. Okay? So that's the segment addition postulate. So the first part plus the second part should equal the whole line. And so we're going to be using that to solve some problems. So I've got two examples. I have example 1, Q is between R and T. So I'm going to go ahead and draw my line R and T. And I'm going to put Q in between it. I know RT is 18, so the whole line is 18. I know QR is 10, so this piece is 10. Find QT. So I don't know QT. Hopefully we can look at that and know that X is 8. Or we could set up an equation and say 10 plus X equals 18 and subtract 10 on both sides. But my missing distance would be 8. Okay, so the length of QT would be 8. So I guess technically we should write QT equals 8. Okay? All right, so those are all numerical answers. We can obviously get some equations involved. So let's look at example 2. Given AC is 39 and B is between A and C. So A and C are your endpoints. Then I would put B in between it. I know the entire thing is 39, so that would be my whole. I know BC, or find BC, so I'm going to go ahead and put X. If I know AB is 2X minus 8, and then BC is X plus 17. So sorry, I couldn't assume to put X right there. X plus 17. Okay, so I've got an equation for A and B, BC, and then I know a whole thing. So I'm going to have to set up an equation. So the first part plus the second part should equal my whole entire line. Okay, so then you just have to combine like terms. So you've got 3x, negative 8 plus 17. And then equals 39. Go ahead and solve that two-step equation by subtracting 9 on both sides to get 3x equals 30. Therefore, x would be 10. Okay, but I'm not done because it wanted me to find BC. So I need to plug in 10, or substitute back in 10 to my equation for BC. So 10 plus 17 would be 27. So BC is going to be 27. Okay, I could check my work and plug X into both of my parts and add them together and make sure they equal 39, just to make sure if you're right on a quiz, okay? So that's the segment angle addition postulate. I want you guys to try number 3 on your own. So press pause and go ahead and try that on your own. Number 3, I got x equals 10, and you do have to plug it back in because we're not done to find mn to get 32. So this was a little bit different because I had a variables on both sides problem when I had combined like terms. And so notice you had to subtract 3x on this side to bring the x's to the same side. So then once you plug in, you would get 32. So let me know if you have any questions on that one. Otherwise, we're going to move on to maybe how it could be perceived as a little bit trickier using midpoint. So midpoint, we know is the middle, so I know B would be my midpoint, and I know it breaks it into two equal parts or congruent parts. So this little tick mark right here tells me that this segment is the same as this segment. Okay, so if something is the same, I know they are congruent and I know they're equal. So what I'm going to do for midpoint, you would say, I know that part AB is going to be equal to BC. And then I'm going to substitute in what AB represented. So 3x plus 4 has to equal 5x minus 6. Okay, I've got variables on both sides and I need to solve them. You can solve it 4 different ways, but I always like to move my variables to the left side. So I'll go ahead and do that. 3x minus 5 would be negative 2x. Bring down your 4 equals, and then bring down your negative 6. Then you've got a two-step problem where you would subtract 4 on both sides. Negative 2x equals negative 10. Divide by negative 2. X is going to equal positive 5. Okay. Now, always read the question. Am I done? It wanted me to find the length of AB, so I'm not done. So I need to substitute 5 back in for x. So 3 times 5 plus 4. 3 times 5 is 15, plus 4 would be 19. So AB is going to equal 19. Okay? If you want to check your answer to make sure you're correct, we could plug 5 back into this equation. So 5 times 5 minus 6. So 25 minus 6 does equal 19. Okay? So it checked out. I know both of my distances were 19. That makes sense for midpoint. My segments are congruent. Okay? So if things are in the middle, midpoint, that's when you set them equal to each other and not use this segment angle addition postulate. All right, 2 more challenge problems. So these are challenging because we've got 3 segments, or 4 segments in these cases, and we need to kind of do some reasoning to find some missing pieces. So on the first one, it wants you to find EC, which would be this whole distance. Okay? So if you think you can figure this out, please press pause and ignore what I'm about to say and give it a try. But I'm going to reason through this. So I know the whole thing is 19, and I know this piece is 11. So I'm going to go ahead and start with that 11 piece. So if that line that I drew was 11, and I know that part of it is 8, I can figure out what this remaining piece is right here. So 11 subtract 8 will give me 3. Okay, so I know that that missing piece, FE, is 3 now. Okay, still trying to find this whole piece. So eventually I need to figure out what DC is so that I can find EC. If I know the whole entire line is 19, I can figure out what CD is by doing 19, subtract 8, and subtract 3 because I already know those pieces. So 19 subtract 8 subtract 3 will give me 8. Okay, so now I know all the individual line segments, and so I can finally find EC by adding 8 and 8 together to get 16. So EC is going to be 16. So on these challenge problems, you do have to reason through, reason through to find each individual piece, knowing these longer links down here. Okay, so that's one way of working through that problem. There was plenty of other ways to work through it. So why don't you try this one? It's a little trickier because we've got variables involved. So try that one, press pause, and then we'll go over it. Okay, so on the second one, it was very tricky. I kind of stared at it for like 2 minutes, but after doing some work, I got x was a 7. So I'm actually going to erase what I did to kind of show you guys how I set it up. So I saw the whole entire thing was 13, and I saw that piece was 5. So I did 13 minus 5 to get 8. So I knew that V was 8. Okay. So then I kind of ignored 5. I didn't really need it from then on out. I noticed that this piece and this piece were the same. So from V to t, that was the same as the x plus 3. And so I said, well, that means that all of this should equal the x plus 3. So I said 2x minus 12 plus 8 should have equaled that x plus 3. And I solved it to get 7. I double checked to make sure my work was right. I plugged in 7 to x plus 3 and I got 10. And then I plugged in 7 into this 2x minus 12 and I got 2. And so it made sense that 8 plus 2 was that same distance. Okay, so that's one way of looking at that problem. There's multiple ways, so if that way does not make sense, I can come explain another way. But that is the segment angle addition postulate. Okay, so you're more than welcome to practice now. Thank you for watching. Let me know if you have any questions.